And have you got audio on the stream now, just to check? Testing audio, 1, 2, 3.
On the stream, Andrew, let me just...
Hi Joe, testing audio again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I can hear something.
Testing audio on the stream, is this working?
I currently do not know. I'm getting some audio on.
Testing 1, 2, 3, one more time.
Yeah, just. I'm not sure if it's getting. Is it capturing your desktop audio to hear us?
I can turn that off.
That works.
So just keep everything enabled, and it's just a bit of a lag.
Well, it works quite well. If people want to watch on YouTube, they can rewind if they get stuck on something.
Okay. Tin Happis, you happy?
Tween Happis.
Jack, Ian, are we ready? So today's workshop will be on machine learning, so we're going to blend a bit of machine learning into Scratch to see how it all works and comes together. So just to give you an idea of what machine learning is, it's the way we program the computer using a set of algorithms so it can learn from different data sets, and provides the computer with the ability to learn without us hard programming what this object is, what that object is. The computer can work out using its data that it understands, and it can make predictions of what things are. So if a car was driving along the road here, it could sense that's a person, that's a car, that's a road sign, and make use of that information. And we use it everywhere. So in a smart house, we use machine learning here, so the machine can learn your day-to-day routine. So if you leave the house, certain things will happen. Okay. So in this workshop, we're going to build a basic smart home interface like Google and Siri, and we're going to do this by using the Machine Learning for Kids website. So in a browser now, if we all go to this site here,
Andrew, what you've just shared is coming up to me as just a white square. The white square.
I will try it one more time. Copy. Paste. Okay.
There it is.
So this will take us to this page here. I'm just going to log back out to restart again. So once you're on this page, you can either create an account if you want to, but for this session, we can just choose this option here. So try it without registering and click try it now. And this is where we create our data set for the machine to learn from. And this is what's going to be used in Scratch. So on the right hand side, select add a new project. And in here we can give it a project name. So I'm just going to call it Smart Home. And for this project, we're going to be recognizing text. So once we've filled out this section here, select Create. And now we can see our project in the center here. So we've got a smart home project, which is going to recognize text. So now we can select into our project. And we have 3 stages of the project before we get to Scratch. We're going to train the project first. So this is going to be us giving it information. And then we're going to test the project to make sure it's working. And once we're happy with these 2 sections here, we move on to creating the project in Scratch. Are we all at this stage so far? Are we here yet? Are you getting any feedback from other sides, Joe?
No, everyone on the chat is happy.
Okay.
It's probably just us watching the chat. No, we've got 7 people watching.
Okay, perfect. So we're on this here now. So the first one we want to do is want to train a machine learning project. So we click on Train. And then on the right hand side, this is where we're going to add labels. So we can select the label. I'll show you how to do this first. And we're going to label this light on. So we have 2 labels, light on and light off. Hopefully. It's a bit slow. There we go. So in each of these sections now, we want to add examples of how we would ask the computer to do something like this. So if we wanted to ask the computer to turn the light on, we might say, turn the lights on. Increase the brightness in the room. Think of different ways you can ask the computer to turn the light on and add these as examples. So we could say light on. Computer will understand your section here and turn the lights on. So we can just try and think of different examples. So add as many as you can. Don't just have 1 or 2 examples of turning on a light. Try and have 5 or 10. And there may be other things you want to add. So if you wanted to add something like the switch on. You can add as many as you want, so that could be light switches, wall switches. You could have anything you can think of. Joe, you might have some ideas of what you could put in.
There's lots of things.
You want to write examples of how you would ask these, so the computer can understand. So you could say, turn off the lights. Leave the room dark. You could write some funny ones like, it's too bright in here. So the computer will understand when you're saying it's too bright, it will dim the lights or turn them off. So just fill these sections here now with loads of different commands and instructions. And if you have other ones of these labels, create your own labels and add instructions into those. So I'm just going to fill out these now. And then you do the same on your computer. So remember, we want at least 5 commands in each one of these. Dan?
Yes.
How do you turn on the light?
How do I turn on the light? Well,
Yeah.
I can see.
If you were talking to a computer.
Well, I would say either. I would say something like.
Bear in mind, Dan is very polite, so he might be more polite than a lot of people are to their computers.
I was just going to say, I would say something like, please turn the lights on, which I've actually added into my list here.
There we go.
Oh dear.
We want as many as you can think of, so more is better. Lights off. Please turn off the lights.
Yes, you see, manners.
if you add something that you don't want or you misspell it, you can select on it like I have here and delete it, and we can re-add that. Switch. And if you're struggling with what labels to use, you could create a label for a specific item. That's perfect. So you could say fan on. And that will turn on a fan somewhere and fan off. So I'm just going to leave mine there and wait for everyone to catch up to have something like this, where they've got different labels with examples in them, how they would ask to get the lights on, the lights off, the switches on, different items in the house on and off. Hi Jack, have you got to the stage where you're creating the labels and examples?
Yeah, there's recognizing text, yeah. And click on the plus button on the right to add your first bucket.
That's right. So you should have something that looks like this in the end. So the label will be the action, and the examples will be how you would ask the computer to do that action.
Okay.
So if you look at my screen, we've got lights on, then examples of how I'm asking the computer to turn on the lights.
Okay, it's just loading now at the moment. So adding the new label, that's what you...
That would be the app.
Okay.
That would be the light coming on, the light going off, switch on or switch off. So that's what the label is.
Okay.
Inside the label, you would have the examples of how you would ask the computer to turn on the lights, turn off the lights.
Oh yeah. Okay.
So if you think of it, the label is the action, the examples are how you would ask the computer.
I'll ask a computer. Open. Would that be? add. So I've added open. And then...
So you've added a label called open. How's yours coming along then, Dan?
Oh, mine's coming along just fine.
Labels have you used?
I have only used the lights on, lights off, switch on, switch off ones so far. I haven't done a fan one yet.
Think of something else. It doesn't have to be a fan. It could be microwave on, kettle on.
Yeah, okay.
Machine on.
What can we
Enable,
do?
disable, that's a good one. Think of the things in your life that you would automate. And they would become your labels, and then how would you ask the computer to automate those?
I am currently adding oven, and
I'm sure yours would be done, like, instead of lights on, uni work complete. And in assignments.
yeah, I am. Yes, that is a good point.
Any questions so far? Yes, yeah. Let me know when you're ready to move on to the next bit. It's a bit strange when you can't see anybody's screen or see anybody. She'll give you a couple more minutes and then we'll move on to training our machine. What other ones did you come up with, Dan?
I have added oven, and then now after doing 6, it actually won't let me add any more. Every time I try and add a new one, it says there's an unknown error. Which is a bit bizarre.
Oh, I don't know.
Yeah, it's a bit weird.
It might be because you're not using an account to do it. I don't know.
It could be that we're capped at so many.
I've got. I don't know. Let's see how many we can do.
Yeah, because I've got a total of 6 here.
We've got over 8 so far. You've done something now.
Yes, I'm trying to rectify the problem.
That looks good, yeah. What happens with Jack's connection? Jack, what happens with your connection?
So yeah, my Discord on my map is just like completely just like packed in, which is a useful feature.
Oh. Where's the master? Hopefully he doesn't start barking. There we go. How's yours coming along, Jack?
What's the problem? I found out the problem.
What's your problem?
My problem, I think, is my Wi-Fi.
Oh.
It has, it's doing something funky. Right, hang on. Hang on. Yeah, right. Hang on.
I think Dan will move on to the next bit now.
Yeah, go for it. You crack on. I'll just try and fix my issues over here.
Okay, just in case anybody types, just keep an eye on what we're doing. In case any questions come through. Jack is still typing. So I think something's happened.
I think I have fixed the issue.
Perfect.
Yeah, it's working.
So once we've created our actions and the examples of how we can get that action to happen, we can click back to project. And the next stage now is we're going to test our project, our machine learning, and to see if it works and how well it works. So we can click learn and test. And then here we need to click train, and it'll train through all of our actions and the examples. So we just have to wait for this to finish. If it takes longer than a minute or two, refresh the page and it should be ready. While you're waiting, there is a quiz. Try and complete the quiz. Joe, are you still there?
Yeah, I'm still here.
I'm just checking. Everything
I'm just
okay
muted.
from your side?
Yeah, I'm just muted because I'm pottering around with the printers.
That's alright. Perfect. So once your model has finished training, you should have an option here to enter text. So now these will be the examples that we wrote into our previous section where we learned the learning section of the machine. So here, if I select type light on, it would work out that we're trying to do the light on command, and we can try and ask it different ways. Please turn on the light. And it's worked out that's the light on command as well. And it also tells us how confident the machine is that we are doing that command. So you could try writing in some text which is a bit different to your examples and see how confident the example is. So just try writing some text in now and see if you can get your labels or actions to appear here and how confident they are. And this is why we give each label or action loads of different examples, because when you write text which is not exactly what we have put in as an example, the machine can learn, the machine is learning and it understands that you're trying to do certain actions from those words in the text that we're using. So just from the text room hot, the machine knows that the room is hot, so we want to switch on the fan and cool the room down. Room cold should give us the other option. Just try cold. Have we a look? Freezing. Even gets commands which are not used. So, Jack, are you at this stage here? So once you've written your actions and examples, select back to project and then click learn and test. And here you'll have an option to test the model. So click test and then give it a couple of minutes. If you don't get this text box here appearing, refresh your page and you should have this option here. And then in here you can write down the examples that you've used or variations of those examples and see if you can get your actions to appear. So turn the lights on would get the lights on action. Does that help, Jack? Has that worked for you, Dan?
It is still trying to do training. I have done some refreshing and stuff, but it is just taking a particularly long time over here.
Your Wi-Fi?
Yeah. It's pretty shocking. It is still training.
Still training.
It is awful, this Wi-Fi.
18% chance of turning the fan off, or confidence, because the sun is out.
Oh, I have success.
So now you should be able to try and add your text in here now. So you can add the examples, variations of the examples. So yours would be, please turn off the lights. Then we'll get lots of action.
It is going well.
So this section here essentially just makes sure that what we've trained has worked correctly. I can hear the neighbours outside. How are we getting on here? Is that working for you? I don't know why I sound like a robot. Perfect. Are you happy with it there, Dan?
I am indeed happy.
I'm just waiting on Jack to see what he says. That was good. Yeah. Dan?
Yes.
If Jack needs help, can you help him in the chat? I'm just going to move on to the next bit.
Yeah, you crack on. I am in the chat.
Just in case, because he has to add some more examples. Because if you have less than 5 examples for a label,
it doesn't let you.
And says add some more. So once we've done that, we go back to this page here. So we've trained it, we've learned, and we've tested our model. So the last thing to do now is make our app. So we click on make, and we're going to be using Scratch 3 today. So we click Scratch 3. You'll be taken to this page. This explains what some of the instructions we'll be using, but I'll explain that anyway. So we can click open in Scratch and it'll take you to a Scratch page. And this is where it gets interesting and cool. Are we all familiar with Scratch? We have our instructions on the left, we have our programming window in the middle, and we have our story and characters and backdrop on the right hand side. So the first thing we want to add, like everything we have a flag. This is going to be a very basic example to start off with. We're going to get the character to say something. So we're going to say hello for 2 seconds. So we'll click on the flag. We're all quite comfortable with this stage here. So when we click the flag here, it does the instructions that are below here. And at the moment, we're not using our machine model. And if you have used Scratch before, you'll notice in the left here we have 2 new options called Images and Smart Home. The only section we'll need is Smart Home because we're not using images today. And these are elements from our machine learning website, which we can use. Okay. So the recognized text. So this one here, I'm just going to zoom in a bit to make it a bit easier. What this one here does, it says, input some text in here, like we did if we go back to here for a second. This would be like this field here. So when we input some text here, the machine will try and figure out what you're trying to ask it to do. And it will give you an output which is one of the labels or actions. So we can drop this into hello. And we can write in an instruction or a command here like turn on the lights. If I can spell, that would help. So now this model is going to input this text here into our machine, work out what action we're trying to do, and then Scratch is going to say that action. So we're going to click on this. It's worked out. Turn on the lights means, I'll put this for a bit longer. Turn on the lights means lights on. So remember, these are these sections here. So if we click on train for a second, the output from the say bubble will always be one of these labels. The input in here will be the variations of these here. So you can try different ones here now. Turn off the lights. Just so you can understand how we're trying to recognize the text and work out what that text is, and then give you the action that you're after. Are we happy so far? Are there any questions? Is that working for you, Dan?
I have not tried it. I've been monitoring the chat, but I have been watching what you're doing, and I shall try it now. If my Wi-Fi was working properly.
Yeah. And yeah, is that working okay for you? Does that make some sense? Perfect. So you can try any text you want in here. It's cold in this room, which is not really. Computer will try and work out what you're trying to say. That time it wasn't correct. Let's have a look. Oh, that is right. It's hot. So using this, we can see quite easily how we're using our machine that we created. We can get actions in Scratch from this. Just going to get some more water.
There we go. It is indeed working for me, Andrew.
Perfect. Have we got any questions so far? Is everyone happy with how we're implementing the machine learning model into our Scratch? I think this is amazing already, that we can type in any text in here and we can get an action and the computer understands what we're trying to get it to do, essentially. Like if we want the lights to come on, we can give it a command through here. And it doesn't have to be specific strings either, which is quite nice. It can be variations of the string to get different commands to happen, which is how like Google works. Google doesn't need very specific strings. It can understand the variations of those strings to get different commands to happen. Are we all ready to move on to the next bits? Perfect, that looks good. So now we've got the basic implementation. We're going to delete this. and we're going to create it like a smart home. So every smart home, you want it to know your name to start with, don't you? You don't want to be user, you want to be known by your name. So the first thing we want to do is under sensing, we can ask a question. What's your name? So when you hit the green flag, you'll be prompted for an input. So you can type in the input, and then the computer will know what your name is. So first we need to add this here. And have we all used variables before, apart from Dan? Dan, what is a variable?
Well, I guess you could say a variable is something that will hold a piece of data within the computer's memory, I suppose would be the best way of putting it.
Yeah, that sounds good to me. So we can here, under variables, we can create a variable. And we can give that user name. So that this is going to be the variable name, which never changes, but what is assigned to that variable can change. So we've got something called username. And here we can do set username. And in here we're going to have the answer to this question. Can you figure out how to get the answer into there? Here we're asking the question. If I go here, there's a nice good hint. Here we ask the question. We want the answer from that question to go here. I think I made that nice and obvious. So we can take the answer instruction block here and drop that into here. So now we can say ask what's your name. Whatever answer we input into here, so I input Andrew, that will be stored against username here. A nice way to check it is, let's add a block in here and say hello. We'll just put username. So we're going to say whatever is stored against the username, this variable here, and we're going to say it for 2 seconds. So we put green flag, my name is Andrew. Then the cat's going to say Andrew. If I change this to my name is Dan, it's going to say Dan. Does this work for everyone so far? And that's another way of checking it. You could also tick the box here, and the username would appear in the top right corner. As you can see, the variable always changes. The name of the variable never changes, but the value assigned to the variable can change. And there's something quite cool which I've only learned recently in Scratch that you can do. If you go into here, the operators, you can do something called join. And join, as you'll see in a second, joins these two strings together. So how could we use that? We could say welcome, welcome, space, and then the username. So now when we type in my username is Andrew, it says welcome Andrew.
So it's like it's concatenating it, right, Andrew?
Exactly. So you could have it that way. So username, welcome to this smart home system. So my name's Andrew. Well, Andrew, welcome to the smart home. Have we all got to this stage so far? So now the computer can capture what our name is, store that name in a variable, and then give us, the user, a welcome message. So this makes the smart home feel like it's our smart home and not just a generic smart home. Are we happy so far? So once we've created the introduction into the program, after this, forever, keyword there, forever, we want the computer to be asking us what commands we want to do. So keyword there, forever, so we're going to need a forever loop, which repeats a set of instructions over and over again. And in here we want the computer to ask us what command do you want to use, and then we're going to use a number of if statements to try and work out what our instruction is and to get our instruction to appear on the screen. So the first thing we want the computer to do is ask us a question. So we can go back to here and we can ask the question. And we could do something similar here. We could join this up again. So we could say, Andrew, what would you like me to do? So now forever, the computer is going to be asking us a question, what's the instruction you want me to do? And so far we do nothing with that answer. So if we hit play now, what's your name? Andrew. Welcome. What would you like me to do? I can write anything in here. It'll always ask me what I would like to do. It will never break out of this loop. There we go. Let's stop that. Are we all happy so far? I'm going to presume everyone's happy.
Well, I mean, I'm all good here, but
So if we go back to our, well, you don't need to go back, but if I go back to my machine learning website, how many commands do I have? 6 commands in total. Light on, light off, switch on, switch off, fan on, and fan off. So we need to take the answer from this question and work out which command we are trying to do. And we can do this with a number of if statements. Have we all used if statements before? Perfect. So if this value in here is true, we do the instructions inside of this block. So any instruction inside this block will be repeated. If the value is false, we skip all the instructions in here and we move on to the next section of the program. So we can drag our if statement into here now. So we're going to ask the question, and then in the if statement we're going to, that's good, we're going to be checking what the answer is. So we need to do something called an operator with an equal sign. So we're going to say if the answer is equal to this value here, we will run these instructions below here. And this is where we're going to need some other elements of the smart home now. So you remember how we used this block at the start? We'd input the random text in here to turn the lights on. And the output from this was going to be one of these here. Can you see this section here? So for this one, this would say turn the lights on. That would recognize that as lights on. If I change this to turn the lights off, I would recognize that text here as this label here. Does that make sense so far? So we need to understand that for this next section. Did that make sense, Dan? Can you still hear me, Dan?
I can hear you. I was just waiting to see if everyone else was.
Yeah. So did that make sense? So we've got a command that goes into here, and then this will recognize that text and give us an output from it. That's how it worked previously. So we're going to drop it into here. We're going to recognize the text. And in here, we don't want to have a set text. We want the answer to this question here. If I go back here and we drop in this here. So the computer's going to ask, what would you like me to do? You're going to write your answer in. Your answer will then be checked against a number of different statements. So it's going to recognize this text, and if that text is going to be equal to lights on, we're going to do this set of commands. And if I do lights off for a second, and if that text is equal to lights off, then we do the next set of commands.
Yes, that makes sense.
So if I go into looks here, just to make it as obvious as I can make it, turning on the lights. So we're going to ask what the name is. Then it's going to ask you, so we're at this section here, we're going to say, Andrew, what would you like me to do? So I'm going to say, turn on the lights. And the answer that I put into here will then be checked against each of these if statements. Then it's going to work out which one it is. So this is going to be lights on, and then it's going to display this text here. So if I said turn off the lights, it would work out that it's going to be this statement here. Hi Jack, yeah, is that making sense? Oh yeah, because you're at this stage.
I'm just in the process of helping Jack out with.
Hi Ian, is that making sense so far? Does creating this section work for you? So I'll just recap this bit here. So we're going to ask the question, and we're going to take the answer of that question, and we're going to put it into our machine learning text, and we're going to work out if that text is equal to lights on, lights off. And you need to do this for each one of the actions you created. So for me, I would have 6 if statements. So I would just keep doing this. If the answer is equal to switch on, turn on the switch. So what we should have in the end is an if statement for each of the actions in your machine learning model. So for each action, we're going to work out if the answer is equal to that action, and then we're going to say text which is relatable to that action. So if we wanted the computer to turn on the lights, it would do this section here. And then it would go back to the start and ask the question again. And you can test it and see what happens. Is that working for you, Ian? Hi Ian, how are you getting on with this section here, using the if statements? Yeah, that's good, yeah, that's good. Have you done one for each of your actions? Have you created an if statement for each of your actions that you had in the previous section? Perfect. So the next thing to do now is, we don't just want the computer to say something. So we're going to create a character or a sprite for each of your actions. So if I wanted to do the light bulb, I would click paint and I would create a light bulb. So I'm going to change the color of it. I'm going to draw a light bulb. And we want 2 costumes for each one. So this would be light on, duplicate that costume, remove the fill, and we'll call this light off. So we have essentially 2 actions for each costume. So I'm going to create one for, what else do I have? The fan, I think. Look. Switch. How can I draw a switch? Maybe. And then we could do something like this. That would be switch on. I don't know. That makes more sense. Switch on. Now how do I do this? This is the worst fan in the world. But there we go. So we should have a sprite for each of the actions. And we can resize these in the window and get them to display. So I'll show you how to do one, and then I want you to try and figure out how to do each of the other ones. So in Scratch we have something called broadcasting. So broadcasting allows each of the sprites to talk to each other. So in our main sprite we can broadcast a message, and we could say, in the event, we can broadcast a message, and we could call this one lights on. So you can have a broadcast message in each one of these, And then we can go into the relevant sprite, and then we can say when I receive lights on, we can switch costume. So we could switch the costume to light on. So now when I say light on here, the light turns on the sprite. And then we could do the same for this one here now. Create a new one, and we can call this one lights off. We can go back into the same sprite, and we can duplicate this, and we can say when we receive lights off, we change the costume to lights off. So each time we do a command here now, something happens in our program. Lights off, and the light will switch off. So can we all see that happening? So try and work out how to do this for each of the other ones. Should be straightforward. We broadcast a message from the main sprite into the individual sprites to tell it to do a certain action. Now in the individual sprite we say when I receive this message, lights on, we switch the costume to light on. You could also add other things. You could add that costume to say something. You could add a sound. So we could pop when the lights come on. And then when we want the lights to turn off, we have a different broadcast message which sends out. So in here when we want it to turn off, we say lights off. When we receive lights off, we switch the costume to lights off, and you could have a sound for that. How's that working for you, Jan? So just remember, broadcasting allows you to transmit messages between different sprites. And hopefully your creations look much better than mine, because that is definitely not fun.
Andrew?
Yes.
Would you be able to, on the stream, show Jack how you got onto the Scratch page? It might be easier than me trying to explain it, because we're at the stage now where we can start moving into Scratch on here.
Okay. Just finish these. Hi Jack, can you see my screen now? Hi Jack, can you see my screen just before I start showing you how to do this? Just to confirm. Yeah, just broadcast message. if I go back to this. We broadcast a message and then we move on to the next instruction. We don't wait for something to happen. Just to speed up the process and the program. Hi Jack, can you see my screen now? Dan?
Yes, Andrew.
Just let me know when Jack's ready to
go
through this. If you are looking, Jack, I'll just do it quickly now. Select Make. Select Scratch 3. And then select Open in Scratch. And when you've created each of the broadcasts and got your sprites doing different things, let me know, and I will show you some other things we can do. Dan, I'm drinking too much water.
You're drinking too much water?
I've had a pint and a half since we've sat down here.
I can see how that might be a potential problem.
Say that again.
I can see how that might be a potential problem in a few minutes.
Half an hour to go. I think I'll be able to make it. You hear me suddenly run out, you know what's going on.
I'll know why. Oh, Andrew and Joe, if you can still hear us, Joe. I have made an expensive purchase.
Oh.
I bought a new gaming PC, which I'm really excited about.
What's the spec?
Well, there's a lot of specs, and it has taken me a very long time to choose the specific specs. However, off the top of my head, I was torn between, for the processor, whether or not to go for an Intel or an AMD Ryzen, and I ended up going for an AMD Ryzen 5 3600X, I think.
AMD's, they're doing so good now with processors.
Say that again.
AMD, for the price you're paying and the processing power you're getting, Intel's just not there anymore.
Yeah, the AMD processor that I've chosen, I think, was on when I was doing like some comparisons. The cost was a lot less, but its performance was on par with like one of the i7 equivalents.
Exactly.
So yeah. I was like, yeah, I'm gonna stick with an AMD Ryzen. 2 terabytes of storage of HDD, 500 gigabytes of SSD, and 16 gigabytes of RAM.
That's not bad.
So yeah, it was all right for the price that I paid for it. It's pretty decent actually. Monitor.
Are you building it yourself or?
No, they're building it for me.
Oh, that's all the fun gone.
I would break it and it would be ruined. I know myself too well to know that I would not be that I would just get frustrated with it and end up breaking something. So I was like, and also actually, I used Part Picker, priced up the parts, and it was actually the same price for them to build it for me than what it was for me to assemble it myself. And I was like, well, do you know what? I'm just going to have them assemble it for me to take some of the stress out of it.
Is that where you were sold on?
What, by the fact that they would assemble it for me?
Yeah.
Yeah, well, it wasn't bad, actually. The price that I paid for it with a monitor and a mouse and keyboard was like 1,480.
I think if I was going to buy a PC now, I would buy a laptop.
What, a gaming laptop, you mean?
Yeah. Just for portability.
Yeah. I think I just wanted a desktop because, like, I've got my Mac for uni work, and then I was like, I think I just wanted like a desktop as well. So
I understand the feel of a desktop, but I just find for me anyway, putting the money into a laptop which is portable.
Yeah, that's
it's
fair.
more efficient for me now.
Yeah.
You have a desktop, it's sat there, and it only gets turned on when I edit photos.
Yeah. Well, I'm going to use it for flight sims, hopefully. The new Microsoft Flight Simulator that's coming out this year. That's what I want to use it for.
Yeah. Will you get the new consoles this year?
New consoles?
Yeah.
Probably not. Just because of how much I've just spent on this.
Yeah, true.
Like, yeah. Well, I used the bursary. You know, the
You're not meant to say that, Dan.
Why not?
It's meant to help your studies.
Well, yeah, but it's going to be used for work as well. Like, it's not just for
like laptop to do word processing.
And technically, it did also fund my Mac, if you think about it in one way, because I bought my Mac for uni, so this has funded my Mac. So it's half on my Mac, half on my new PC. So it was a wise spend of the bursary.
Yeah. Fair enough. How are we getting on, yeah? I used to spend my money on cars, Dan.
What? You spent your bursary on cars?
Yeah, I can say that now because I've graduated, but yeah, that's where it...
Oh, wow.
So that's where it went.
I'm pretty sure the disclaimer is still there. No, at the end of the day, like...
I had a new car every year, Dan.
Strictly speaking, what I was going to do was I was just going to save it and then use it when I needed it. But the thing was, I thought it was just going to sit in my savings account, and because I'd pretty much already bought everything that I needed for uni, like new Mac and all my stuff, so I was like, it's just going to sit there otherwise.
Yeah.
So, and because I can use the PC for bits that maybe need a bit more processing power than what my Mac can handle, I thought it has a dual purpose there, really.
Yeah. As Joe would say, I've spent my savings. If I need money, that's my future self problem.
Yeah.
Now me is happy with the computer. My future me can worry about that.
Yeah, it was. I think it was a good investment, really. I needed a desktop PC for. So I thought as well, if I've got a decent monitor, which I think 23.5 inches, I think, I was like, oh, that'll be plenty big enough if I need to do like multitasking on with bits of uni work and stuff. Like, it's going to come in really handy.
Is that just one screen, 23 inches?
Yeah.
Oh, I couldn't do that. 27-inch screen I bought, but if I bought a new screen now, it'd be ultra wide. I wouldn't have anything else anymore.
Yeah, I wanted a big screen for doing gaming on it, but the thing itself, it's going to be so handy for uni work. Like, trying to do the stuff on it.
Yeah, exactly.
It's like when I'm trying to do stuff on here, it's just like everything is squashed and really small windows.
Yeah. Like with working from home, I've got my own monitor hooked up to the work laptop.
Yeah.
So I can watch a film while working. No.
Yeah, no, I'm really excited about it. It's going to be really handy and stuff, and it's because it's Windows as well. It means I've got a Mac machine and a Windows machine, so it's going to make life easier for uni, definitely. So it was a bursary well spent, in my opinion.
Yeah. You could have got a Raspberry Pi 4 gig.
I could.
£50 or whatever it is, something like 47.
How much? How much are they?
I think you can get them for about £50 for the 4 gig version.
Oh, okay.
Hi Jack, you'll be able to watch this recording back and go through at your own pace anyway. But thank you for coming along.
Oh, is there? Yeah, and a cheaper one, Raspberry Pi. Oh, okay.
Yeah, there's a 2 gig version and a 4 gig version.
Oh, right, okay.
I think there's about £15 difference or £10 difference maybe. Okay, that makes sense. But I had a look down at how much it would cost to have a Raspberry Pi 4 gig version on 24/7 all year round. Do you know how much it would cost?
Say that again, sorry, you cut out.
I had a look at cost of having a Raspberry Pi 4 on 24/7 all year.
Oh, yeah, okay.
How much do you think it would cost in pounds?
All year, so 24/7 all year to run the Raspberry Pi. Well, it can't be that much because it's only tiny. But then again, it packs a punch with its processing power too, doesn't it? So
let's go see what your guess is, because I wouldn't have guessed this.
Okay, all year round, Raspberry Pi. Okay.
This is off somebody else's calculations. I've just Googled it and found the answer.
Okay. I reckon to run it all year, 365 days a year, I would estimate in the region of like maybe, I don't know, somewhere in the region of maybe 250 to 350.
£100.
It's £100.
No, is that what you said? 200 to 300?
Yeah, 250 to 350 pounds, somewhere in that vicinity.
It draws so little power, yeah, that somebody it would cost about £12.
£12? That's pretty amazing that something like that will only kind of like, use £12. That's really, really good.
Let's have a look. I'll do this on a separate screen. Come on, screen.
Well, that's pretty good value.
I'm just going to double check it. Let's have a look. Give us a price. look here. Raspberry Pi 3 B+. Running a Raspberry under maximum load should cost no more than roughly $5 per year.
Roughly how much?
$5. I'm just looking at different sites to make sure.
$5?
Yeah.
That's like what? £2.50? £3?
Yeah, exactly.
Crazy.
Yeah, somebody else here has worked out £1.24 per month if you were paying 17 pence per kilowatt. Yeah, so it's no more than £15 if you're pushing it.
That's pretty crazy. Yeah, and I'm just watching your
Yeah, and me.
video you sent through.
I like how you've gone into a lot more effort than me.
That's really cool. It's all pretty good though, yeah. I'm like, oh, you took one from school?
Again, are you able to send over your code just so we can have a little look to see how you've written it? Yeah, that was good. Was that easy so far? The sunlight's on my screen now. Hey, Ian, are we ready for the next bit? Where we can add more instructions and get our machine to learn new phrases without having to go back into here. So we're going to add more examples of each one of these. So once we've asked all the questions, we can ask another question. Well, this is slowing down now. And here we can say, do you want to add new examples to your actions? And then we can say, if the answer is yes, we're going to add new examples into each one of these actions. So do you remember how to do this? If the answer is equal to yes, we're going to do this segment of code.
There's an issue with the YouTube live stream, I think, Andrew, on my end.
Yeah, I think my computer's slowing down a bit now as well. Joe is alive, I think. He's there somewhere.
Hello?
Oh, hello, Joe.
What's up with the stream?
The YouTube stream seems to have frozen a little bit, unless it's working on yours.
Let me check. I can check the stats.
It could well be my Wi-Fi.
The YouTube one was being funny earlier anyway, so...
So hi, Ian. So we're going to ask the question, do you want to add more examples to your actions? And if the answer is yes, that we want to add more examples, we're going to do this section of code here. And then we're going to do something very similar to what we have here already. So we're going to say, which action would you like to update. So we need to know which one of these we're going to add an example to first. And then we're going to say if the answer is equal to, and then we write the label down. So light underscore on. So this would be each one of these labels. So it needs to be spelled exactly the same. So if the answer is equal to light on, or you can write it if you want it, so we could say light on. Then we're going to ask the question again. What example would you like to add? And then we're going to use this method here called, I'll zoom in a bit now. Add the answer to, so this example, so one of these, so a new one, to that action. So I'll just go through this from the top. So the first thing we need to do is ask if we want to add an example to our action. And if we do want to add an example, we're going to do this section of code here. So we're going to ask which action would you like to update. So we need an if statement for each one of our actions. So if the answer is equal to lights on, we're going to update this one here. And what example would you like to add to this lights on? And then whatever you write in there will be the answer. And that answer will be added to this library here. And once we've done that, we need to do train new machine learning model. So if we are adding something to our machine, we need to train it at the end of this if statement. So we would then do this. Zoom out. And then we would do this for each action we have. So for lights on, we would add the answer to lights on. For lights off, we would just change this. So what example would you like to add? The answer would then go into lights off. I'm only putting these here so it makes a bit more sense, like a comment in the code. Does that make sense, Jan? We ask if we would like to add an example. If we do want to add an example, we need to find out which action we want to update. Once we've found out which action we're updating, we then add the example to that action. So we can do this for each of our actions. So we'd need to do this 6 times. And then at the end of this, we need to train the new machine learning model. So I'm just going to add these in for all of them now. And then where we train the new machine learning model is at the end of that if statement. So we don't need to have it in each individual block. We can have it at the end of that if statement. So then we can have switch on. Switch on. I'm only adding these here as a comment. They are doing nothing. So now not only can we use our machine learning model, we can also update it in Scratch and essentially increase how productive it is and how well it works. Zoom out a little. So once you've done one of these if blocks here, you can just right click and duplicate it and add multiple ones in and then just change the relevant areas rather than recreating each block from scratch. Dan, I will be back in a minute.
Okay, that's fine.
How are we getting on? Are you following along as well, Dan?
I haven't been for predominantly because, and I'll tell you why, I was relying upon the YouTube live stream, which packed in, and then came back. But in order to watch the live stream via Discord, I would have to go through my phone because that's the way I'm talking, because otherwise the mic on the Mac isn't very good. And the screen is very tiny, so I can't really see what I'm doing. So and also I lost track a little bit at one stage because I was
Helping.
monitoring the chat, so then I got a bit behind. So I've just been monitoring the chat now instead.
Just scan through it in YouTube and try it out, because it's quite cool what you can actually do with it.
Oh, no.
You can actually use this. I think, if I'm right, I think that we've had another session this week in Swansea, and you can create one of these in here, and you can do it in Python and App Inventor. So you could have an app which uses the machine learning model, which is quite cool.
Well, machine learning on my phone does the whole thing of knowing my sleep schedule, so that it knows when to charge my phone past 82%.
Okay.
I'm not sure it does that. Optimized charging, Apple call it, apparently.
Optimized charging.
So when it's like charging overnight, it will stop at 82% until like 6 a.m. because it knows that usually I don't get up before 6 a.m. So it won't pass it beyond 82% until after 6 a.m. so that it knows that it doesn't kill the battery by being on full charge all night.
Okay, yeah. How have you got on with adding the update to the machine learning model? Are you able to share your Scratch game itself? So click on. Oh, we can. Is there a way you can share your project? No, you can't, can you? Wow.
It doesn't look like we're able to actually share it yet.
No, because it uses. I just looked at the link. You're still in Machine Learning for Kids, and they just basically got Scratch on their website. You can't actually share it.
You could save it to the computer and then upload it as an attachment.
But I think it won't work because I presume this is linking directly with their servers rather than going out to Scratch. We can try. Let's see if this downloads.
Let's have a look.
I might lose mine now, but it's fine. Fingers crossed this works. Perfect. So this is. Can I go? No. What's your name?
It's trying to load it in on mine here.
Should have read the question.
Yeah, it doesn't want to load it on mine.
Nope. Yeah, it's working. I can see it's working here.
Oh, it does. Oh, okay, that's good.
It has worked.
It's probably because mine is by default tried to open it using Safari.
Yeah. What you can also do now, I'll show you this quickly, but we are running out of time. You can check how confident it is with the system. Okay, I'm doubling up here, so I think we're using this one. So we could say something, say how confident we are with the answer, if that makes sense. We can say recognize text, and we can check the confidence of it, and we can drop this into here. And we could say recognize the answer for 2 seconds. So if I start this again, type in my name, and lights on. So it should tell us how confident it is. So it's 100% confident that we're turning the lights on. In fact, we could. Rather than having to write this into everyone, we could say it straight after. So we could say, recognize the confidence, and then we'll check. If that makes sense. So we're going to say, what's your name? Type this in. Turn on my lights. 93% confident with what it's going to do. Turning on the lights. Does that make sense? Yeah. Cool. We can do the same thing, and we can join this word. So we could say let's say join that with a percentage symbol. So now if we did this one more time, what's my name? 81% confident, turning off the lights. So we can understand how confident the system is with doing an action. We could complete lights switch on. Let's see what happens. 89% confident, turning on the lights. So we can this just allows us to understand our model. So we could say if it's less than 50% confident, we don't do anything. So you could include something that looks like this. You could say if so you could say if the recognized text is more than 50% confident that it's correct, we do a set of instructions. If it's less than 50%, we do nothing. So we could put all of this inside there and then drop that back into there. So we only do any of these instructions when the machine is more than 50% confident that it's got the correct answer. And you could be really mean. You could say if it's more than 99% confident, then we do it. So let's try that. I'm going to try and make it not work. Turn the lights off. So 87% confident, so it shouldn't do anything. Does that make sense? So we could even have this in an if-else statement. So we could say if If it's true, then we do our set of instructions. If it's false, we can get it to say something. I'm not sure what you want me to do. So inside the recognized text layer, you'd want to have the answer where it says text. So yeah, that would work as well. So now we've got a system which only does something if it's super confident, and if it's not super confident, it won't do anything. It'll just tell us turn them lights off. 77% confidence, so it shouldn't do anything. I'm not sure what you want me to do. What would you like me to do?
I'll probably have to go now, I'm afraid, Andrew, if that's all right.
Yeah, we're coming to the end anyway, Dan. But thanks for joining me. Give me a bit of company.
Yeah, let me know when you're doing the next one, and I'll join in. I've pretty much submitted everything now. I'm just waiting for another assignment to be set and revising for a test, so I'm a bit more kind of free to do bits and bobs now.
Oh, okay. That's good to know.
So if you're around...
The next one of these sessions, unless we have another one in between, is on the 29th.
Is on when, sorry?
29th of April.
Oh, the 29th. Oh, okay, the last one, instead of the M-Spark Club.
Yeah.
Okay. That's fine.
Enjoy your Easter.